We are going to do a very short unconstrained optimization example with Nastran Solution 200. The goal of this video is just to show you the fundamentals of Nastran Solution 200. What is an optimization problem statement? What is an objective? What is a variable? What is a constraint? All the basic terminology, some fundamental concepts will be covered in this tutorial. Here's the example we will be working with. We have defined this function as you see here on the screen. It's defined as x1 squared plus x2 squared. Our objective is to find the minimum of this function, and we are going to use the optimization capability in Nastran to find the minimum for us. So let me go ahead and switch over to my desktop. Again, I'm going to go through the fundamentals of Nastran Solution 200 optimization. I'm also going to show you each step you need to take in order to set up this problem. So here, go to the web app and open the size web app. This is going to load this new web app. First, load the PDF file for this example, and we'll go ahead and click upload. The web app identifies all the properties we can set as design variables. Currently, we are in the variable section, as you can see here in the top, almost left-hand corner of the screen. We also have an objective section, a constraint section, and so on and so on. So to start off with, let's create our design variables. So if I go back to the graph, we see that we have two design variables, x1 and x2. They have starting points of 3, 4. So let me go ahead and go back here and show you where this initial point is. So we are going to start at 3, 4, and we are going to let the optimizer in Nastran find the minimum given the starting point. So let's go ahead and define these two design variables. So let me go ahead and search for this property and this property. You can see the initial values here are 3.0 and 4.0, just like the graph I displayed a moment ago. So we're currently here at this point. I also need to create a third design variable. We will go ahead and ignore this design variable for the remainder of the tutorial. This is just a requirement for Nastran Solution 200. So now let's go ahead and define our objective. We will create a custom equation to describe our objective. Now, one thing I should note here is the optimization problem statement. This is a summary of your objective, any constraints, and your design variables. Here, I've already defined my problem statement. My objective is to minimize or find the minimum of this function given design variable x1 and x2, and the starting point is 3, 4. Now, we've already defined our design variables. Let's go ahead and define our objective function. So here we want to minimize this function here. So let's go ahead and step back and do that. Here I'm going to go to the objective section, click on equation objective. This is where I can type my objective function. And of course, we want to go ahead and minimize this. And there we have it. So that's it in terms of setup. We've created our two design variables, x1 and x2 that you see here. They have a starting point of 3 and 4. Then we went ahead and defined our objective equation. We want to minimize it. And now we can export our newly converted PDF files here on the left and our design model here on the right. So let's go ahead and click on option 1. This is going to go ahead and download a new zip file. What's special about this zip file is that you have all the PDF files that you need to run in Nastran, but it also includes an option to automatically run Nastran for you. So let's go ahead and double click this file. You'll notice it'll do a number of things. One, it's going to open the status page where you can track where the optimization is. Number 2, once the optimization is successfully complete, it's going to load the results for you. Just as a reminder, remember that our minimum should be at 0, 0. So let's go ahead and plot the search. Here you can see that the minimum is 0, 0. And let's go ahead and look at what the Nastran optimization produced. So we started at a value of 25. So here, if I go back to the graph, you see that at 3,4, I started at a value of 25. So that would be this top left-hand corner. It might be worth doing the following. So here, let me see if I can be slick about this. And what I'm going to do is rotate the graph so that the graph sort of matches what's happening here. It would be worth moving this a little to the left too. So here at the beginning, you can see that we started at a value of 25. So here we started at a value of 25. And then steadily decrease until it hit a value of 0 that you can see here at the bottom. That's exactly what happened. We had the first design cycle, second, third, fourth, so on and so on until the 9th design cycle. You can see here, so the first, the second, the third, fourth, and so on design cycles. Now, I should also mention that this plotting capability shows you the value of the design variables over each design cycle. Here, the solution has values of 0, 0 for x1 and x2. That's exactly what happens here. We start up at values of 4 and 3, and we slowly arrive at values for x1 and x2 of 0 and 0. So there you have it. That is what's known as unconstrained optimization. The reason being because there are no constraints. The optimizer was allowed to freely find the minimum without any constraint whatsoever. In the next video, we are going to go over our first example of a constrained optimization example.